I'm really glad that Ronen Feldman could join the program because he is one of the founders of text mining, text analytics as a discipline that can be applied in the kind of industrial settings that we're all here to learn about. So I'll just turn it over to Ronen now.
Thank you. Good. So what I'll start to do is I'll give a brief overview of sentiment analysis. It will be really brief. And then I'll move to talk about the progression of the technology from the old days of rule-based technology to the most sophisticated machine learning technology. I'll show you some examples how you can use it. And then I'll turn to two major applications. One application is how to utilize news analysis for stock trading. I'll show you a system that we are actually partnering now with Dow Jones with. And the other thing that I'll show you is how to mine user forums, mainly medical forums. I'll show you the type of analysis and what kind of visualizations you can get out of it. Okay, so let's start. So basically, I think the definition, it's clear for everyone who wants to see inside a specific lexical context, what is the sentiment towards a specific object. And we'll talk about the different levels inside a document, inside a sentence, inside a phrase, or inside a word. So if we start actually from the word level, we definitely have 4 different levels that we want to find. And sometimes we need to go to the phrase level because any individual word doesn't have a specific meaning, but when you get the full phrase, then you have actually a sentiment about it. And then after the phrases, we have the sentence level, and finally the document level. So here are some examples of positive, negative, subjective things about the variety of the part of speech classes, adjectives, verbs, nouns, and in many cases, one of the tricky parts is the fact that you can flip the meaning just by using one word. So if we'll take, for instance, prevent bone loss. So bone loss in general is a bad thing, but prevent bone loss is a good thing, so you need to automatically determine that this is actually a positive thing. In many cases, things are even more complicated than that. And you want, inside the same sentence, you want to see that there are multiple sentiments, and you want to figure out one part is positive, one part is negative. And in many cases, it might be that one part refers to one object inside the same sentence, and one part refers to the other object, and you don't want to mix those things up. So there are 2 major approaches when you try to do the classification at the document level. Either you can do it in a bottom-up approach. In this case, you actually give sentiment to the words, and this is one of the classic ways that many of the vendors use. You propagate it, and then you give a score to the full document. Of course, the problem, it's very inaccurate. In a top-down approach, you get labeled documents. People do label the full document, and then you try to determine just by using all sorts of statistical methods, you try to find what is the sentiment of a specific word. So let's go now deep into the technology and see what are the major components in terms of the linguistic analysis that we have. So at the lowest level, we have tokenization, basically breaking things into words. Then we have the morphological analyzer, assigning a part of speech tag to each of the words, noun, phrase, adjective, etc. We find the breaks of the sentences, assign all sorts of metadata analysis, and then we start with basic NLP, identifying noun phrases, verb phrases, and then after we finished with the specific low-level linguistics, then we move to the semantics level, and then we find entities classify the entities into the types, people, people, companies, drugs, tissues, proteins, depends, of course, which domain you are working in. And finally, we have the events and facts. Facts basically are things that do not depend on time, and events are things that have a timestamp. In many cases, a change of event would lead to a change of one set of facts to another set of facts. So all the examples that I'll use our engine called CARE. CARE is actually a hybrid system that combines rule-based with supervised machine learning, at least at the basic level, and then I'll show you how it can progress. So the idea is that the named entity recognition, identifying all the entities, is done by a CRF, conditional random fields, which is basically the most sophisticated graphical algorithm to analyze sequences, and rules that enable you to do the analysis. In many cases, just having the linguistic engine is not enough, so what you need is two more components to augment it. One component is actually how to analyze an HTML page, get rid of all the garbage, find only the things that you're interested in. I'll show you actually a machine learning-based system that you can train visually to learn what things are important and what things are not, which means that the training data is training process is extremely fast, and then you can get accuracies up to 98%. The post-processor is in charge of aligning entities to say that they mean the same thing. So what people would say, discourse analysis, co-reference resolution, so all of that is done in the post-processor, basically the standardization process of all the things. This is actually the evolution of information extraction technology in general. So at the bottom, actually before my current company, I founded ClearForest that later was sold to Thomson Reuters. And the basic language that ClearForest was using, still using, is Dial. You can see it in OpenCalais. It's only rule-based. The problem, of course, is that it takes too much time to develop rules. I think everybody that developed rules knows that this is the major pain point when you try to move to a new domain. So ever since 1997, I tried to find better ways how to reduce the amount of time in order to define a new module for information extraction that can be used for whatever. Sentiment analysis, text analytics, building databases. So the level after the manual rules is the supervised machine learning, hidden Markov models, conditional random fields. And then we thought one of the good things to do would be to do a hybrid. Let's combine the two approaches together. So this was the first version. But then again, we saw still we had to write too many rules. So in order to reduce that, we introduced into the system a basic algorithm that basically knows to parse any sentence. But it's integrated inside the information extraction engine. It means that most of the rules can rely on this basic algorithm, and you don't need to write as many rules as before. The reduction in the number of rules that you need to write is 1 to 10. So it's a huge reduction in how many rules you need to do. But again, we saw that we still had to write some rules. So the ultimate thing is actually to use unsupervised machine learning, which means that you don't need any user input. In the supervised machine learning, people had to annotate documents to give examples. At the latest incarnation, we don't need any examples. Basically, we just need a big corpus of text, and the system will learn the rules automatically. And I'll show you some examples actually later. So this is actually one example of how we utilize the automatic rule learning to mine medical forums. So, you know, those are forums that people talk about. Specifically, this is diabetes. So people talk about drugs and what symptoms they have. In order to do such an analysis, typically you would have to write a lot of rules and really fine-tune it. Here, we did not write even a single rule. So all the analysis that is done here to find all the connections between drugs and symptoms were done fully automatically, and we identified also when was a positive connection. Note that actually the colors are reverse to the sentiment, because if it's positive, it means there is a positive connection between the drug and the symptom. So it means in this case, actors and weight gain have a positive connection. It's not good. I mean, most people don't think that weight gain is a good thing. So in the sentiment perspective, this would be negative, but here we are talking about the connection between the drug and the symptom. And all the rest are the negative stuff. What you can do now is you have millions of documents. You want to summarize it. So then we build diagrams that basically show you all the connections between the drugs and the symptoms. And using color coding, you can see when a drug actually causes something or relieves a symptom. So you really get a full summary of millions of documents, and the idea is that you can click, it's all interactive, you can click on a link to get back and see, okay, show me the sentences that support that this drug is causing this symptom. Here are diagrams that show which drugs were taken together. It's very important for physicians, stuff like that. The first big application that I'm going to talk about is how to do sentiment analysis from news sites. So first, let me convince you that you need actually hybrid sentiment analysis. It was actually a question that was posed previously to the panel. Look at the sentence. If you look at the sentence, most of the words that are mentioned inside the sentence are positive. Still, the sentence is clearly negative. So if you work here in a dictionary-based approach, you'll get to the wrong conclusion. But if you have the ability to identify events, in this particular case, a voluntary recall, in this case, you'll see that it's a negative event. So even though many of the words are actually positive, still the whole sentence is very negative. Okay? So I'll explain you the architecture of the sentiment analysis system. And I think this is a typical architecture for almost any sentiment analysis system. So first, we go to all the different websites and take the content from them. I told you before about this visual system. So this is the visual system that you train the system how to identify what is important and what is not. Basically, it finds all the frames on the page, and then you click red. It means the frame is not interesting, but then inside, this is the green one is interesting, and again, inside, it's not interesting. So it's like a zigzag till you get to all the parts that are relevant. So after we found all the content from the different websites and we did the cleaning, then we actually go to identify what are the relevant sentences or sometimes even phrases to a particular company. In many cases, you have articles that talk about market movers. I don't want text that talks about AT&T to affect Citibank. So I want to identify exactly what are really the phrases, and in many cases, within one sentence, you may have sentiment about two companies that are totally opposite, and you want to capture which sentiment refers to this company and which sentiment refers to the other company. So this is all done in the pre-processing. In the hybrid sentiment analysis, we combine three levels. The first is the dictionary-based, which is the most simplistic. We'll talk about it in a minute. Then we have the phrase-based, because as we saw before, just working at the word level is not good enough. We want to move to phrases. And finally, the events. So we identify all the different events, and we identify if the event is positive or negative for the company. After we have all those elements, each element has a different weight, and the weights, of course, can be changed. You can get a score for the document. The score is between -1 and 1. -1, it means The article doesn't mention even one good word about the company. One, it means it's really positive. And of course, very smoothing, so that even you'll have one word, you don't want to get one for the company. So a classic smoothing algorithm would be used. And of course, you don't have a single document. You have many documents to talk about the company. So what you want to do is you want to use a decaying effect. So if the article is older, of course, its weight should be lower. So you can get a weighted average from all the documents that talk about the company, and finally you get a score for the whole collection. So this is the hybrid approach, combining the three different approaches. And now, so this is the dictionary-based. Probably you know that there are many sentiment dictionaries out on the internet. I'll mention some of the most famous ones, the Harvard Inquirer, Bill McDonald from Notre Dame has the financial set, and there is SentiWordNet, and there are a few others. So the idea is really to get the best dictionary out of there, so you take all the different resources, put them together, use all sorts of machine learning algorithms to really create the best of breed dictionary here. The event-based, so all the classic business events that you can think about, acquisitions, mergers, new product introductions, dividend hikes, whatever. I mean, there are dozens of different business events that are identified, and in each case, characterized if the event is positive or negative for the company. Here are some examples. So what you see here, you see three graphs. So the three graphs, the green one is the positive sentiment, the red one is the negative sentiment, and the blue one is the stock price. So of course, the most interesting thing is in terms of sentiment is to identify early warning that something is either going up or down. So in Macy's, here you can see that we had a big spike in the sentiment and the stock did go up. It's not that always it will happen. Of course, the main thing is to use sentiment as an additional signal. You don't use it alone. You use it with technical analysis, you use it with fundamental analysis, but what we saw and proved it, that basically when you do introduce the additional signal, you get much better results than by not using it. Some more examples here. JCPenney, you can see a very strong signal that something bad is going on. So if you would go to a short position at that point, you would actually do pretty well. Monsanto, it's a very interesting graph. And you can see that really there was a very strong prediction. This is actually 6 months. So it's the past 6 months for Monsanto. And you can see the system really identified very well what's going on. Just by the way, I think now, I just looked yesterday, the system predicts that actually Monsanto in the, not the immediate future, but the next future is a very good stock to invest in. Goldman Sachs, you can see also a very good detection before the fall in the stock. This is a very small pharmaceutical company, and you can see really the system identified really early that something interesting is going on. And so if you got into the system around the low, where actually it was the strongest signal, then that was a pretty wise decision. I want actually to show one example I saw in the attendee list that this is actually Expedia. I saw people from TripAdvisor in the audience. What you could see here is definitely there was a big drop on Expedia when they missed earnings, but then there was a very big spike when they started to, the big spike in the stock price was actually when they announced that they are going to spin off TripAdvisor into a different company. But you can see that even before the big spike, we had a very early warning that it's a good stock and you should get into. I actually did. Okay, so let's go back. One of the things that I want to show here is you can see everything, the system explains why. So you can actually see highlighted in the text why there is a spike in the sentiment. So it's not a black box. You really get to see the explanation. So let me go back now and talk about medical forums. So this is a classic text mining process. In this particular case, we wanted to mine forums that talks about diabetes. And so you need to go to all the different forums, download all the pages, clean them as we talked before, and then go deep into the sentiment analysis. What you can see here is that we found all the major forums for diabetes, downloaded all the different elements here, all the different pages, messages that people talked about. Of course, one of the most important things in forums is to keep the structure of the forum. You want to identify threads and individual messages, because in many cases, when somebody says yes, you want to say yes to what? So you need to understand the context just by looking at the previous messages. So here you can see a summary of all the diabetes forums. The width of the line represents the frequency, how many times a specific drug was compared to another drug. So of course, for pharmaceutical companies, that's very important to know immediately how the competition, at least the perceived competition, is changing. And you can do all sorts of clustering here. Here, drugs that are, again, taken together, and again, the width of the line shows how many times such a connection was spotted in the messages. And here, probably one of the most important things for a pharmaceutical company is the switching. People say that they switched from one drug to another drug. And that, of course, I think is the holy grail that we are seeking to see early on what people are saying. And here you can find the side effects. And what we did here is we used the lift. The lift basically represents how much is the probability of seeing B affected when we see A. So A in this case is the drug, and B is the symptom. So if it doesn't change, then the lift would be 1. But if we're talking about very high lifts, here it can go as high as 18. It means that there is 18 times more probability that we'll see a symptom when it is connected to a particular drug, which is very, very interesting. So you can see for Byetta, which is one of the diabetes drugs, you can see that nose running is the one that has the highest lift. And you can see a variety of other symptoms. So those are, most of the cases, those are the bad symptoms that you get from the drug. But you can also put it in context when you want to show connections to other drugs. So previously we just focused only on one drug, just on Byetta. Here we focus on a set of drugs, the leading drugs that actually have connections, to show which symptoms are shared by more than one drug. Here are some positive things, so it's not only negative symptoms, you can also see some positive symptoms here. helps with hunger is the most noticeable one for Bayeta. And again, the network view of positive sentiment for the drugs. The last thing that I want to talk about is actually how to utilize Twitter to find the expert investors. So again, this was done with same tools that I showed you before. And what we try to find is really, most of the people that you read on Twitter, I'm talking about stock tweets. Most of the people just don't add any real value. There are very few people that really know what we're talking about. And the idea is to really find those diamonds out of all the massive garbage that you have inside Twitter. And we really try to find really a handful of really good investors that is really good to follow. So I'll show you the approach, how that was done. And so initially we wanted to identify, of course, to classify the messages into bullish or bearish according to the specific stock. And here you can see the classification. There are many different types of tweets. There are tweets that just are news, tweets that really somebody said that they are trading, all sorts of speculations, and just sentiment. We really wanted to focus on people that do things, not people that just mumble, but people that said that they bought, they are long, they are short, so really actions. Here you can see the pie chart that shows the distribution of the different types of the tweets, stock tweets. And I won't go into all the details here. I think the most interesting thing, first you can see finding the precision recall of the buy and sell decisions was pretty high, definitely something that you can use for the model. And what I'll do is here, you can, you don't see the line of the random, but it's at the 50 level point. And what you can see is when we actually took a joint expert model, we managed to get to around, it depends of course how many experts you use. So if you use really the best experts, then you can get even to 65%. Of course, there are very few experts like that. So if you include many more experts, you can still get to a 54%, which means that if your commissions are low enough, you can still make money, but you can cut actually the curve at any point that you want and get exactly the return that you want if you follow these experts. The last thing that I want to show, and then I'll wrap up, is actually all of this is done inside a tool that is like Visual Studio. So we call it Visual Care. And this Visual Care actually enables you to define rules. It actually learns the rules automatically. You can refine it. And I'll show you one example. This case is an example of corporate. And you can see it parses the things for you and shows you exactly why a specific rule was decided to hold. If you want more details, I'll be here the whole day. And that is it.